Definition of probability is defined as a number. There's a number between 0 up to 1, and this number going to tell us likelihood that an event going to happen. After we do a calculation, let's say the number that we got equals to 0. If we want to use a layman term, a normal term, tell our friends the event A will never going to happen because after I did the calculation, the number is 0. 0 is not going to happen this event. If the number that calculated is 0.41, we can use the normal words, maybe going to happen. When we calculate and we got the value equals to 1, we're going to say that this event guarantee is going to happen. How can we calculate the value 0 up to 1? We can use the general formula defining the probability. We're going to count everything numbers. How many quantity? This will reflect as the denominator. How many possible ways, how many possible happenings, how many possible outcomes. How about the denominator? That will be our preferred event quantity, our preferred number. Why we want to know this number 0, 0.41, 1.0? This is because the number help us to predict the future. Example, let's say one of our friend going to visit us at the Chile campus here, and our friend don't know whether he need to bring the umbrella or not. We're going to tell him, you need to bring umbrella or not? The answer is yes, because 100 days when we are at the Chile campus here, we found that there are a total of 41 days is raining days. When we divide the raining event, the number is 41, and the observer times is 100, we have 0.41. We can use the layman term to say that maybe going to rain because 41%, 0.41 probability is going to rain on the next day. Means that we would suggest and recommend our friends to bring the umbrella to the campus. When we are calculating the probability numbers 0 up to 1, how can we know which formula that we need to use? It will depend on how many events that we are calculating. If there's only one event, we can just simply use the general formula to find what will be the probability. When we want to draw the one event into a Venn diagram, most likely we're going to draw it a big rectangular to represent everything, and then there is one circle to represent the event A. The blue color box is the case when we have 2, 3, 4, 5, 6 or many events involved in our probability calculations. And then these events can be divided into two subgroups. The first one, if all those events has no overlapping, there's no sharing people inside those circles. When we look at this one diagram here, we see that each of the event, M is the male, R is using the right hand, M is the male, L is using the left hand to right, F female, R is right hand, and F female and L is left hand. We found that there is no same person overlapping inside those two events. When we have this scenario, it falls under the mutually exclusive events. No overlapping elements. Nobody is joining the sharing group, the sharing event, the sharing box. The formula that we're going to use most likely is these two. The union between event A and event B will equals to the summation of probability event A and probability event B. Then since there's no intersection between all those events, so there's intersection equals to 0. There's nothing there. There's no overlapping, nothing between those events. For the case that overlapping, for example, we have males, boys, that besides they use the right hand to write, they use the left hand to write. A minority use both hands to write. They are good at both hands. For example, right, left, both hand. This will be the overlapping elements, people, male, that it can manifest inside our Venn diagram or inside our contingency table here. There are 4 males that very good using right and left hand to write. So it will appear at the overlapping this red color area here. We call it as the intersection between those two events. When we have this kind of events happen, there is overlapping. We call it not mutually exclusive events. Some elements, some people, some students, they are overlapping inside 2 or more events. The formula that we're going to use will be these two. When we want to find the union, the OR case, or we want to find the AND case, the intersection, those will be the formulas. There will be a special case if we are given a scenario that what would be the probability of happening A given the event B happened already. This will be the formula. We will have a total of 3 examples. The examples are taken from the main slides. Look at the first example. There is a table here, and this table is called the contingency table. It shows the how many males and how many females, and how many males are using their right hand as their main hand, and how many are using their left hand. So same goes to the females, right hand and left hand. Now, in order to get more from the given raw table, it is a good practice that we're going to add how many males, how many females, and also how many using their left hand and how many are using their right hand. When we have this information, we can confirm that the final numbers from each of the event will be the same. So from the sexes will be same 100. From use either left or right hand, when we add up both, will show 100. It will same as the given information, 100 individuals inside this big class. If we want to convert this table into a Venn diagram, we can do so. There is no overlapping. Means that most likely we're going to use the mutual exclusive events case to do the calculation. We can draw the Venn diagram. We can draw 4 circles. Means that this big class, we're going to form a small 4 classes. And then we'll ask that male and use their right hand go into the small class. Male and using the left hand, we'll ask them to let's go to the small class. Female using right hand, let's join the small class. And female left hand join the small class. When we go and count how many person inside each of the small class, it will reflect the same. 43 will be male and right hand. Here, 43. Male using the left hand will be 9. female 44 using their right hand and 4 using their left hand. So the table, contingency table, can be converted into the Venn diagram. And why Venn diagram? Because it can help us to define whether this fall under the mutual or not mutual exclusive events. We'll look at some of the probability calculation here. Let us look at the E. E is one to find the probability to get somebody that is a male and using their right hand. Means that from these 100 people, we're going to close our eyes and randomly pick somebody. And what would be the chances that we're going to pick that person is a male and also right hand? So when we look at the contingency table, male and right hand is 43% individuals. So divide by the total, the everybody will be 100. It will reflect as 0.43. We look at G. What would be the probability that we close our eyes and then we randomly select from those 100 people the everything number, and we're going to get either or male or a female. So this is quite a tricky question because if we logically try to imagine the scenario, there are male and females individuals, and how we pick one time we're going to get the preferred event, male or female. Let us look at how can we get this guarantee picking. That will be 100% one. So to get the male or female, because of the union, we can expand it into P, probability of getting male, plus probability of getting female. So male is 52 here, divided by 100, plus female is 48, divided by 100. So we get 100 over 100. That will be equivalent to 1. So G is 1. Let's look at the I here. The probability of getting female or left hand. When we look at the contingency table, female and left hand, there are 4. This will be the intersection. How about we getting a female or a left hand? We can use the union formula to find it. This will be P of getting the female plus P of getting a left hand. We need to exclude the intersection of those 9 people because they overlap. Even though this is a mutual exclusive scenario, however, when there is so-called overlapping, the existing of the intersection numbers there, we still need to use the non-mutual exclusive formula. So we're going to minus how many is female and they are using the left hand. Probability of getting a female equals to 48 100. Probability of getting a left-handed is 30% over 100. We need to exclude the probability of the overlapping numbers here. Sorry, it will be 4, sorry, not 9, because it's a female and it is left-handed. There will be 4 over 100. So later on, we're going to get 0.57. Okay, we'll go to the M case. M case, it has there's a symbol straight down. I don't know what it's called. However, in the probability context, we call it given. What will be the probability of getting a left-handed, given that we already asked all the females to come into another classroom, gather together? This is conditional. What is this called? Conditional probability formula. It will be expanded to probability of left-handed intersection with the female divided by the probability of getting the female. So now we're going to pull the numbers from the left-handed intersection female, left-handed here, and intersection female. The number is 4. So 4 over 100 individuals, the everything number, divide by the female probability. Female we have 48, divide by 100. So later on the number is 0.08. Next, this is the second example. It's quite similar to the first example. We have a contingency table. For this case, there are a total of 755 drivers being surveyed, and there are a total of 305 drivers that using their handphone, 450 drivers that not using their handphone during driving. We found that from the same this 755, there are 70 that they were fine. They got the summon because of the speeding. 685 clean, no summon because of the speeding. We look at question C and E. For this case, C, we want to find what is the probability driver had no violation in the last year, and intersection overlapping was a cell phone user. Look at the no violation column here, okay, and was a cell phone user. We're going to highlight the column and the row and find what is the intersection. 280. The number is 280. Divide by the total drivers being surveyed. This would be the answer. Let's look at the probability of finding the driver is a cell phone user, given driver had a violation in the last year. Okay, driver is a cell phone user here, and then given that the driver had a violation last year, means that we already sort out the no speeding violation. We ask them, okay, go to another room. We just asking those got the speeding fine, the violation, come. Then we want to check what will the probability if I close my eyes and I select from the 70 people here, the chances that they are using cell phone during driving. We're going to use the formula, conditional probability formula. It will equals to the key, a cell phone user, yes, then yes, violation. So the formula says that it will be the intersection between yes using the cell phone, yes violation, divide by yes violation. So cell phone user and yes violation is 25 driver, divide by total everything number is 755, and then the yes violation is 70 people, divide by 755. So after simplification, we get 25 over 70. We shall look at the last example here. We are given 40% of the student belongs to a club, and then 50% work part-time. And then we have 5% of the students, they work part-time and they belong to a club. Now we are asked to draw a Venn diagram to represent these three groups. See whether there is intersection between the part-time and also the club. We found that yes, it consists of the 5%. We're not sure how many students actually inside there. We just know that there's 5%. How about for the part-timers? So we're going to use the horizontal line to show the part-timers. Based on the information here, we have a total of 50%, quite a lot. And we use the vertical line to show the club student. There are 40%. Now we want to find the probability the student belongs to a club. Okay, so we just extract, get the number from the statement there. There'll be 40% equivalent to 0.40. We'll look at the last two questions here. The probability that the student belongs to a club given that the student worked part-time. The probability of the student belongs to a club and the student is working part-time. So using the conditional probability formula here, it will be expanded to probability of college student intersect to the part-time divided by the probability of getting part-time. So the intersection between the college student and the part-time based on the Venn diagram and also the information above here, it is 5%. So we just put in 0.05, same as the number here. And then the probability of getting a part-time is 50%, 0.50. So later on, we'll get it is equals to 0.1, 10%. And the last one, the probability that the student belongs to a club or work part-time. When we write in terms of mathematical symbols, expression, belongs to a club or working part-time, we can state it as the C union part-time because there is the intersection or there is overlapping, means that we can guarantee use the formula of the union. P plus P part-time minus the intersection C intersect to PT. So we'll plug the percentage given from the statement there. 0.4 plus 0.5 minus the intersect 0.5. So finally, the percentage is 0.85. The probability is 0.85, 85%. Come back to the reason why we want to learn the probability is because that if we know the number, the probability number, we can do a good prediction for our future. Again, we know that from 100 days we staying in Jelly campus, we found that 41 days raining. One day, our friend come and ask us, should I bring umbrella to Jelly campus? I want to visit you. Because if I bring umbrella, okay, it's going to be inconvenient for me to bring the umbrella to Jelly campus. We'll tell our friend that you must bring because 0.41 probability or 41% of the time, we're going to have rain in Jelly campus. Okay, that's all for the chapter 6. Later on, you can go through the whole content of the lecture notes inside the PDF under week 05. And also remember to complete the YouTube short, the details inside the week 05 eCampus. And all the best for your tutorial 5 submission by this Friday before 10 p.m. Okay, see you. Bye.